So I think there's like several levels of understanding asynchronous JavaScript. There is, level one is I don't, which is like a place, right? Like I started as a Ruby developer, and when I switched to like JavaScript, like I just literally didn't know why that variable was undefined. I literally just called it beforehand because I didn't get how any of it worked. Then there's like level two, which is I think where a lot of us live, which is I don't really understand how it works, but if I know that I use .bind this and throw everything in that callback, everything's fine. Right, and I lived there for a really long time, and then I got this unpaid gig where I had to write documentation for Mozilla, and I had to like actually understand how it worked, and I like figured out like what the browser was doing under the hood, and once I got there, then like everything became a little clearer. So my job in the next 25 minutes is to kind of compress that down and try as best as I can to get you all the way there. You ready? All right. So my name is Steve, which I feel like we covered, so I don't really need to go into that. I live in Colorado, and I don't know how to ski. Those are the important details there. I work at a place called SendGrid. If you've ever taken an Uber or late night bid on something on eBay and got an email about it, we sent you that email, along with several other billion emails every day. I actually work on a WYSIWYG HTML editor that makes HTML emails, so like Ben's talk about 1999, I live there. Ask me about Outlook later. I am perpetually working on a book on Electron. I finished writing it in October, and then in May, Electron 2 came out, so I updated it. And then they announced the Electron 3 beta, so it's just never going to be done. Yeah, cool. When I kind of tweeted earlier today, I saw like those cool signs outside, and my friend Brian Sinclair said that I should rename the talk Asynchronous JavaScript Actually Explained, or AJAX for short. I told him I was going to use in this talk, and this is what he said. So the important note here is that you should outsource your conference jokes to your friends, and then everyone thinks you're funny when really you just have funny friends. So we're going to talk about a little bit about our relationship with asynchronous code. And I guess that starts out with like, what does asynchronous really mean? And we're going to find out the only way that you can truly learn about anything, which is to torture some metaphors. So we're going to run some errands, and we're going to learn about asynchronous code in the process, maybe. So two things I need to do. I need to pick up a prescription from the pharmacy, and I need to go to Safeway. And I don't wear glasses, but that's the best I could do. So step one, if I was doing this synchronously, I would take my prescription, I'd go stand there and wait in line as somebody wanted to argue with the pharmacist about what their insurance did and did not cover, as if that was going to help anything. And then finally, I would pick up my prescription, and I would go along my merry way. I would finish one task, and then I'd go on, and I'd go down to Safeway. Do y'all have Safeway in Omaha? What's the grocery store around here? What's that? Cool. I didn't have a Safeway until I moved to Colorado, so that's a new thing for me. And I can go, I give them some money, and in exchange, I get some carrots, or a carrot, and I move along it's expensive these days. Life is really hard. I go ahead, and now I want to run them asynchronously. So what is the kind of difference there? The whole thing with asynchronous stuff is like a non-blocking thing. I almost liberated a balloon there. Where I can show up again, and I'll drop off my prescription, and then while they're handling all that with my prescription, then I will go down and I'll go shopping. I will shoplift a carrot. I got 25 minutes. I can't do every animation every time, everyone. And then eventually I'll go ahead and pick up my prescription, and I'm good to go. So now it's like asynchrony is almost a form of concurrency, right? I can kind of do two things at once. While I'm waiting for one other thing, I can go do something else, right? There are some like catches here, which is that functions in JavaScript run to completion. So again, let's go back to our metaphor. I go ahead, I drop off my prescription, head on over to Safeway, and I flash them some money. I get my carrot. And while I'm shopping, my prescription's ready. Now, I can't just like leave the grocery store with this carrot, because that is illegal, right? They will prosecute me. They have signs that say this. I can't stop what I'm doing. I have to finish what I'm doing at Safeway, flash some money, receive my carrot, and then I can go ahead and I can pick up my prescription, right? So we have to finish what we're doing in JavaScript. So just because, and this is the whole like JavaScript is single-threaded kind of thing, which is half true. But it actually solves a lot of concurrency problems where like you're going to finish the thing you're doing. So if new information comes in or something else happens, it can't really change the state of what you're currently working on, which solves a whole series of problems for us. And it is great. Cool. All right, so we've got some metaphors in place. What does that run to completion look like? What does it mean to run to completion? It really means three things. One is that an error is thrown and not caught. That will like blow everything up and you're done. Two is that you return from the function, which is you complete it. And three is there's no more code in the function, right? And so in JavaScript that returns undefined. In other languages it might return the last thing, so on and so forth. All right, so then the next question is, why do we have, why is asynchrony important? Why is non-blocking important when building user interfaces? Most frameworks for building user interfaces have some idea of asynchrony because it's important. If you're going to have a user interface, multiple things are probably going on. So here's an example. We've got this little box that I made. It's very cool. I'm selecting some text. If I hover over the buttons, I'll get some CSS hover events. Everything's really great. I hit that start blocking button. And you'll notice that my animation stopped, all my CSS transitions stopped, I can't select any text, like game over. You're like, how did he block the browser? This is how I block the browser. Yeah, open source. I'll put it on NPM later, you can all install it, it'll be great. I'm pretty sure it's secure. Cool. All right, so now we have like some of the basics of why it's important and what it means. How does it actually work? So asynchronous JavaScript is based on events. The same events if you've done any jQuery or just vanilla JavaScript with the DOM, that same idea of events. That is, for every promise library you've ever used or observables or whatever, under the hood, there's probably an event happening, right? A lot of times we use abstractions that hide a lot of that. We don't have to deal with it, but there it is under the hood. That's kind of the level that we're going to talk about today. All this stuff happens under the hood because all the fanciest asynchrony library that you've ever used is still based on a few simple core language features. So we're going to explore those today. So, all right, how does synchronous code work? Right? It's like a Tarantino movie. We're like jumping back and forth. It's okay. It's intentional. So in programming, we have this thing called the call stack, right? And that's keeping track of where we are in the execution of our program. So here's my program. I have an array of possessions. I have a life savings. It's 25. 25 what? I don't know. But that's it. I'm a millennial. That's all I have. And I got two things I'm going to do. I'm going to go grocery shopping, and I'm going to buy some. When I'm grocery shopping, I'm going to buy some vegan ham. So that we'll have those different functions that we run. If I have enough life savings, whatever unit that is, I will purchase some vegan ham. If not, I will throw an error saying I don't have enough money, and then we will execute the go grocery shopping function, which will execute the buy vegan ham function, so on and so forth. So what does that look like in the call stack? We kind of start the program at the top level. Okay, we declared a bunch of functions, but the first function that we execute is go grocery shopping. Cool. That immediately calls buy vegan ham. We run through that. I decrement my life savings. I push vegan ham into my array of possessions. Who amongst us hasn't done that? And that finishes up the vegan ham function, which then brings us to the end of the go grocery shopping function, which finishes up my program. Now, if it's in the browser, it's just going to chill out and wait for other events. If it was a Node program, it would we'd be done. We'd be kicked back out to bash. Neat. All right, let's change this code a little bit. I'm also going to buy some organic almond milk, which is very expensive. It is 20 of whatever, which is going to cause a problem when I go to pick up my vegan ham, because I'm not going to have enough life savings anymore for this, right? So this is going to be a little bit different. So we'll run through this code again. The first piece of code that we actually execute is go grocery shopping, which then calls the buy organic almond milk function. Neat. That executes just fine. We run that to completion. Cool, now we're going to go grocery shopping, or now we're going to the next function, which is to buy the vegan ham. Things aren't going to be really good here. That's going to blow up. That's right, I used that thing in Keynote, and I'm not even ashamed of myself. And it's going to blow up the entire call stack. You're like, this is interesting. You've seen the call stack before. It's just you don't have fond and warm fuzzy feelings about it, because this is usually the context in which you see the call stack, is when something has blown up, right? They'll show you everything that happened between where that initial fire started and all the ways that escalated up. Cool. All right, so that's synchronous code. How does asynchronous stuff work? So the asynchronous stuff goes in this thing called the event queue, which we kind of check repeatedly with the event loop. Remember when I said when you're in the browser, the page doesn't close when your JavaScript stops running, right? That would be bad. I mean, you could probably do that. That'd be kind of cool. But it's probably bad. It kind of triggers on wait for like click events or all sorts of other events that could happen. So we've got this queue. With the call stack, it is first in, first out, right? This is, whatever. I'm not live computer sciencing terms, right? Like we start from the top thing and work our way down. This one we will take whatever came first, like a normal line. And we'll go ahead, we'll handle the first one, then the second one, and then finally the third one. Cool. Where it gets a little more interesting is how these two interact, which is we can only check the event queue with the event loop whenever the call stack is clear. So anything that's in the queue will wait until the call stack is clear. If it's clear, it can kind of move over because we keep checking the queue whenever the call stack is emptied. More stuff comes along. If it's empty, just go handle it in the order that it was received. All right. Neat. So I lied to you at the beginning of this talk, which is always fun to open with lies. It's a way to build trust and friendship amongst your audience. There's no such thing as asynchronous JavaScript, which is also a lie. For the first 20 years of JavaScript, there was no mention of asynchrony in the JavaScript spec. JavaScript was asynchronous as Ruby and Python and all the other languages where you didn't have to deal with asynchronous code. Right? In the ES 2015 spec, there's this little thing about a jobs queue that has to do with promises, but let's just live in a world where the spec still doesn't say anything about asynchronous code. Because generally speaking, we had promise polyfills before that was in there. Let's just make believe that little detail doesn't exist and just go with the idea that there's no such thing as asynchronous JavaScript. You're like, how am I going to actually understand a thing that doesn't exist? I don't know. So most of the things we think about as asynchronous actually comes from the environment. Right? And what is the environment? Well, it's whatever browser you're running in, or Node in this case, so the lack of a browser, but V8 in that case. And in the window object, you've got the whole DOM, which is separate from JavaScript. Right? That's a set of APIs that you can use, and you call it with JavaScript methods, but it's separate from the JavaScript programming language itself. And then we have this other thing called the behavior object model, or the BOM, which is all the things that we think are part of the JavaScript language, but if you read the ECMAScript spec, aren't in there at all. And so it's set timeout, set interval, XML HTTP request, fetch, request animation frame, all those very browser-specific ones. Some of those are ported over to Node, not all of them, but they're not necessarily part of the JavaScript language, and most of them are implemented in C or C++. If you just do set timeout in Chrome DevTools, it'll just be native code. It won't show you the function definition like it would for a function you wrote, because it's actually not in JavaScript, right? So there's no such thing as asynchronous JavaScript, but let's just ignore that. So one example of an asynchronous call is set timeout, everyone's friend, which will, in this case, it takes a function that you want to call, and then some amount of time that you want to wait before that function is called. And it's very, I think a common mistake is that a lot of people think that this will execute in 500 milliseconds. That's not true. It will be added to the event queue in 500 milliseconds, right? Which, if there's stuff in the call stack, it's going to sit there and wait until that's clear, right? We saw that earlier. So it's at least 500 milliseconds. That's why if you're trying to do smooth animations, set timeout or set interval are not your friend. Stuff like request animation frame is probably a better bet, because this is at least 500 milliseconds. So if you're trying to get buttery smooth stuff, that's not going to work. So here we are. We have stuff in here. We're going to throw a set timeout. That's going to wait for that 100 milliseconds, and then our buddy's going to sneak in. That function that has that infinite loop of while true, it's going to sneak in there, which is, yeah, after 1,000 milliseconds, that's going to be added to the event queue and never called, ever. Right, so you'd be hey, if you want to try this at home, a really great example of a blocking function, one of the last true blocking functions in JavaScript that you can use is alert. So you can do something where it sets a timeout and then immediately calls an alert for you say set timeout 1 second later. Then you fire an alert and then go make a sandwich or something, right? It will block that code until you dismiss that alert, and then everything on the event queue will begin to get cleared out. So it's a really great way to kind of visualize that. And you might be neat, you made that I don't have infinite loops in my code. guess what you think. I don't have infinite loops that I know of in my code, is usually what that means. But there's still cases where it doesn't have to be infinite to be problematic. So if you have any kind of expensive task, we've all seen that thing in like Chrome or Firefox where it's like, this script is taking longer than expected. Do you want to kill it or keep waiting, right? That is something that has taken too long, and somebody wrote that line of code. Me. But like, there are ways that you can actually take advantage of the event queue and the event loop to make this easier. So you can use timers, or you can how to make your pages more responsive with one weird trick. So, all right, here's a contrived example. We have some expensive batch task that's going to iterate through 10,000, a million records and do something expensive for each one. It could even just be updating the DOM, right? So what we could do is we could iterate through this really, really large array and do stuff, but that's going to, again, like block up the works. So like we'll keep going in there, they'll stack up, and stuff will end up in the queue and never really like get executed, right? It'll just wait, click events. Also, it'll basically have the same effect of when we saw the animation stop and the CSS hover stop. It's not great, right? What we could do is we could go ahead and like basically take advantage of the event queue to split it up, which is like we're going to put each individual one on the event queue, which means stuff like click events and all sorts of hover, like other events can kind of get in the middle of that line. So we can have a click event, something expensive can get in there, an animation can happen. We can start to interleave stuff that the user did with stuff that our really expensive function is doing, right? And yes, you could also like pull it off to a web work and and maybe just do it server side, right? Yeah, all those are possible, but this is like, you know, one that I could fit on a slide, so that's great. So now it'll go through all those things. Neat. All right, now the most common way that we're going to use asynchronous JavaScript is likely that we are going to make an AJAX request, right? And you have probably never written this, and as I go through this code, you'll see why, because it's terrible, and why would you do this? But the way it works is you make a new XML HTTP request, you have a load event, you have an error event, and then you open it with the method and the endpoint, and then you send it. And then that load event will trigger, or the error event, depending on how this goes. Right? And so that's how just vanilla XML HTTP request works. Most of us use something like Axios or jQuery, $.AJAX, something else along these lines. But under the hood, that is the kind of like native browser implementation. So one pattern for doing this is the callback pattern, right? And callbacks aren't anything special. That's the nice part about first-class functions in JavaScript is that functions can be passed as arguments to other functions. Exhibit joke. Cool, and so here's an example. We can pass in a function as an argument, and then we can call it inside of that function. Like this is a silly example of a callback pattern. So let's take that XML from before, and we're going to refactor it. I took out error. We'll deal with that separately. So what are the kind of pieces that can change here? Well, the callback when it loads, right? The method and the endpoint. So we take all those, and we go ahead and we just make a new function where we're going to pass those in. Do a little copy-paste action, because like that's how you write code. And you just take the parts that are going to change and replace them with the arguments that pass in, right? Now we can go from this big mess of code to this. You want to use it again, you don't have to write that code all over again, you just use your new callback pattern, right? You've effectively invented a very bad version of $AJAX in jQuery. We have no error handling in that, so we need an alternative approach. Now, jQuery does it differently than Node did it, right? And we can kind of look at some of those, right? Which is we had the load, but what about when things go wrong? So we can have the callback there. If we have like, let's say greater than 400, we're going to say like, hey, this didn't go well. Otherwise, we're going to do the right thing. So we'll have the error callback. Oops. We'll have the error callback and the regular callback, and we'll be able to like have both, right? Node handled this a little bit differently. So here, this is the jQuery model. We'll pass in, hey, here's a callback if things go well. Here's a callback if things go poorly, right? The Node way of handling this is to go ahead and have one callback where the first argument will always be an error, the second argument will always, or further arguments are the good stuff, right? And then going ahead, if things go poorly, we pass the error in as the first argument. If things go well, we pass the right stuff in as the second argument. So then we do something like this to have our error in good state. Cool. Callbacks have problems. You can usually only do one thing with that. Like once that function is over, once it's run to completion, you don't have any of those variables anymore. They're now out of scope. You can't really store the result anywhere because of that. Like you can get really creative with the window object. Please don't. You have to be creative with with error handling. We saw that. And basically, it's like, with that, it's like you're putting some function that you wrote onto the event queue and saying, hey, whenever that comes back, here's a function, go call it. If it's something like billing or something like that, you don't know that somebody else, whoever you handed that function to, isn't going to call it like 6 times, right? You've given that function away. It's outside of your hands. You've given it to the event queue, and you hope for the best. And then like, there's always that like pyramid of doom, right? If you need to like go ahead and like, okay, we need that data to call the second one, to call the third one, right? And so this is like, I want to get all of the members from all the organizations that I'm in on GitHub. Like, you get that like pyramid of doom as your code gets just scooching further and further to the right. And now you have to, this moment you have to scroll horizontally in your text editor, you know something has gone terribly wrong. Cool. Like it could get, like that code that I should show you could get worse. That's finding like the fellow members from one organization. If I wanted to find all the members from all the organizations, this, you can just see that this pyramid just gets worse and worse and worse. So in like more and more cases. There's libraries like the async library, it's available on NPM, that will solve this, right? But there's we have other tools in the language now. One of which is promises. And so jQuery supports promises, where you can actually just make an asynchronous request, and you can store it into a variable. And promises, like jQueries aren't technically promises, they are deferreds because they don't follow the promise spec, right? You can just call them all venables if you want to seem cool. We're just going to use the word promise as a generic thing today. So you can say, hey, basically you go back an IOU when you call the asynchronous request, right? It's like, yeah, I'm going to hit that endpoint. Here's an IOU that is eventually I'm going to have something back from the server or an error. You're like, cool. When that comes back, then go do this other thing, right? And whatever that payload of data is will get passed into that function that you pass in. And what's cool is that it solves a lot of the problems of callbacks. We can do multiple things over and over and over again. And you can also do cool stuff like chaining promises. Right, so here we can have the promise.resolve just immediately creates a promise that has resolved, right? So this will resolve with 2 in that data. So you can be like, okay, cool, console log it. Or you can add 1, and that will return a new promise. Every then returns a new promise with the return value of the previous function, right? So here we'll have that 2, then we'll add 1, now it's 3. Multiply by 2, it's 6. Take it to the second power, it's 36, so on and so forth, right? You can take that original one, you can store it, and have it back again as a 2. You can do a lot of really interesting stuff, because instead of giving away that function where you don't have the control anymore, you actually are in control. You have it all on your side of the equation, and you can do interesting stuff with it as you need to, right? And promises, like love them or hate them, are also interesting because a lot of other really cool stuff in the language, like observables and async await, involves promises as well under the hood, right? So you could even be using promises in cases that you don't know you're using promises. All right, cool. So here, like, if you just need a more practical example, here's our $AJAX from before. We can have a function called render post, which will receive a post and like make some markup for us. And then we can, every time we have the request, we can map it through that. And we get much cleaner code. We're like avoiding that like pyramid of doom that we had before, which is very cool. So then we can like go ahead and like do something like add them to the page. There is a problem, though, which is we do need to solve for that error state. Right here, we'll throw a new error in the middle. That's not great, because the promise is counted as rejected. So what we do in that case is that we catch errors at the very end. If you don't catch them at the very end, then like other stuff can go wrong. So you usually keep your catch. If any promise along that entire chain rejects, you can handle it somewhere along the way. And you can say, oh, sorry, we couldn't get your stuff, or whatever. Most of the time, we're consuming promises. Sometimes we have to make them. If you have, yeah, that's always problematic. If you have to make them, right, you can just use the new promise constructor, which takes a function, which passes in resolve and reject, which are also functions. And basically, if good things happen, you call resolve with whatever that data was, pass the good things in, they'll get passed to the .then. If bad things happen, then you'll go ahead and reject, and everything will work along those ways. So let's go ahead and refactor that callback pattern real fast. All right, so this is the callback one. We're simply going to return a new promise where we'll have the resolve and the reject. We'll take that code and we're going to cut and paste it, right? And now instead of calling the callback, we're going to get rid of that, and we will reject in the case that it didn't go well, and we will resolve it in the case that it did, right? And there, we took a callback pattern. I'll show it to you again. We'll take that callback pattern, we turned it into a promise pattern. That's it. Right? That's all the black magic of like making promises, which unless you make a library, you don't have to usually, you consume promises like 99% of the time, but occasionally if you don't have, if like, oh, this is giving me callbacks, I don't like callbacks because I watched a talk and he said they're problematic and now I use promises, you can actually just wrap anything in a promise as well. There's some cool things like promise.all, which will basically take an array of promises, and if they all, so now you can set a whole battalion of network requests, and if they all come back, then you can go do a thing. There's promise.race, which I have never actually found a reason to use. Sorry. And that will actually come back with the first one, right? So the first promise that resolves, you'll get that one. I leave it as an exercise to the reader. So promises always run to completion. That was a lie. Also, you'll notice I have an asterisk. Asterisk will create you a generator function. And generator functions can actually kick back control a number of times. This yield instead of return, every time we yield, we go back to the scope that called it. We kind of go back in the call stack in that case. So yield 1, 2, 3, I can make a new generator. And I can say .next, the first time I'll get 1, the second time I'll get 2, the third time I'll get 3, and eventually the function is actually to completion. And so we can kind of like leave a function and come back in, which is kind of neat. The really interesting part, which again is super confusing to see on a slide, so I apologize for these slides in advance. I'm going somewhere with it, I promise, is that you can actually pass data back in. So here's a function where we will actually yield out that argument that's passed in, and then come back in and store something into a constant. So we'll pass in A, originally we'll go ahead and we'll yield A, and then when we come back again, we'll actually store the next thing in B, and then finally we'll have A plus B. And so the way that works is like, we call it, we get back that A, then we call it again, we pass in the 2, and then finally we get both of them combined. So we passed in something, we left the function, we came back in with more stuff, we got stuff. And so it's kind of interesting because like sometimes we saw with that like multiple callbacks before, like you need to like get some information and do some more stuff. Like this kind of interplay of like, thank you for some information, let me give you some, and like we can like build more complicated asynchronous flows is really interesting. So sometimes we need to wait for a bit of information, and now we have the ability to pause functions and come back to them later with more information. So hey, to put stuff on the page, I need to fulfill this network request. I have to wait for that. So why don't you let me do something else like handle a click event, and when we get back from the network, we'll come back in and pick up where we left off. Right? So you could write some terrible code like this. This is using generators. You can see I'm making 2 API requests. I have this like request thing, which is just like using that AJAX function with the promise that I made before, and it's kicking off the generator every time with the it.next. And so I yield each time, which is I leave that function as I wait for the network request to finish. And every time I get the next piece of data, I can store it in a constant and move along. And I have to do this like kind of interesting stuff here where I've got the function main, like I'm a C programmer or something, and then I've got these yields in there. They seem interesting. I've got this like part right here where I'm kicking off the generator again, which has to kind of be in a global scope, which is gnarly. And then to kick off my entire program, I have to do this. This is kind of gross. It works, but it makes me feel bad inside. But interesting fact, if you take promises and then you mix them with generators, and then you just throw in a bunch of syntactic sugar to make believe you didn't just see all that code to just show you, you know what you get? Async await. That's all async await is. It's promises and generators and some black magic and a curtain so you don't see any of the darkness that's actually going on in those things. So yeah, if we bring them together, here we can go, and we have this code from before, and we just say, hey, this is an async function, and we replace those yields with await. All of that sadness is gone. Error handling, you get the try catch that's in the language, which is fine. And that, again, that AJAX function is the same promise one that was based on the callback one that we looked at earlier in this talk. Right, so you can do a whole bunch of really cool stuff. I wanted to get both simultaneously. I can use promise.all in an async function and await it, because it's all promises and all generators under the hood. So none of this is sorcery. It's just JavaScript, which arguably is sorcery. And all the other like crazy things that you've like read about in like JavaScript Weekly or Hacker News or whatever is mostly some combination of events, promises, and callbacks. Right? And so there are a lot of other interesting patterns out there. They're all based on this. And like once you have these foundations like kind of like you've wrapped your mind around them, like I think you're ready to like there's not like, oh, this library, I don't know how it works. Like you now have like all the foundational pieces in place. So yeah, all that kind of fun stuff is based on literally the stuff that we just spent the last 25 minutes and 30 seconds and 177 slides on. So thank you very much.